Hello everyone and welcome to today's program. This is our How Does It Work series, and today we're going to learn about heat. Let's start by learning about exactly what heat is. Heat is actually a form of energy. When atoms and molecules move faster and faster, that energy that's given off is heat. The movement of the atoms, that energy that's given off, the heat, is measured in temperature. So that's Fahrenheit or Celsius depending on where you live. The colder the temperature, the slower the atoms and molecules are moving. The hotter the temperature, the faster they're moving. If those atoms stop completely, that's when you reach absolute zero. That's when nothing is moving and the temperature is so cold that it's at zero. When it hits absolute zero, it's not giving off any energy and there's no heat at all. Heat only moves into colder temperatures, so it goes from hotter to colder. That's where the energy goes. Think about a glass of ice water. It gets colder because you put ice in it, right? Not really. The heat inside of the glass, in that warm, tepid water that you just get out of the sink, goes into the ice that you put into it. You might think the coldness from the ice is flowing into the hot water, but it's actually reverse. The heat energy in the warm water is going into the cold ice, heating it up and melting it. That's what makes your drink cold. There's 3 different ways that heat can travel: conduction, convection, and radiation. Conduction happens when objects are physically touching each other. So when a hot object is touching a colder object, or metal is touching a pan. Conduction only happens when objects are touching each other. A perfect example of this is our ice metaphor. The water is touching the ice cube. Convection is when heat is transferred through the air, or a gas. You may have heard an adult say, heat rises. This is because of convection. The hot air is lighter than the cold air, so it rises to the top. This is also what makes boiling happen. The hot water at the bottom of the pan rises to the top and pushes the cold water back down, creating a giant circle. So it'll go up from the bottom, circle around the sides, push that cold water back down, and then that water heats up and it goes back up, and it's a never-ending cycle. That's why you get bubbles in hot water. Lastly, radiation is heat energy that travels just through air. It doesn't touch any other object at any time. Radiation is when heat travels purely through air. This type of energy is what comes off a hot stove or a burning fire. That type of heat that you feel is radiation. The last quick thing we need to learn before we move on to our experiment is what insulation is. Insulation is something that acts as a barrier to losing heat. So it's like when you wear your coat on a really cold day. Your coat traps that heat in and keeps it close to your body and forces it not to escape. That's why it keeps you warm. While humans have coats, other animals don't, unless it's your dog during the holidays and you put a sweater on it. Other animals use something called blubber to keep them warm, especially if they're in the ocean. Think of a seal or a penguin or a whale. The reason why they're nice and plump is because of that blubber. The blubber keeps them warm in the frigid cold temperatures. So our experiment today is going to help us understand how that blubber works on other animals and why it keeps them warm. For this experiment, you're going to need some sort of thick liquid. It could be vegetable oil, canola oil, olive oil, or dish soap. You're going to need a nice big bowl, a funnel, duct tape, scissors for that duct tape, 2 Ziploc bags. You can use bigger ones, but sandwich bags work just fine, and some kind of stopwatch. I'm going to use my phone. Also, you're going to need a lot of water, enough to fill up your bowl, and a lot of ice, because we're trying to get this really, really cold. So I'm going to go fill this up. Now that you have your water filled up and your ice in it, this is going to get really cold, and that's the important part. We want this to be really, really cold. So next, you're going to take one of your Ziploc bags and turn it inside out. Once you have that flipped inside out, you're going to put it inside of the other Ziploc bag. Once you do that, you're going to want to try and push the 2 Ziploc closures into each other. So you want to zip one bag onto the other. but you want to leave a little portion open so we can do the next step. So zip it mostly closed. It's okay if it doesn't zip completely or if it doesn't zip at all, because we're going to put some duct tape around the top. Again, leaving a little bit of our zipper free so that we can do that next step. So once you have it taped and you've left a little bit open at the top, you're going to want to put your funnel right into that gap so it's in between the two Ziploc bags, and you're going to want to pour your liquid, whatever type you used, whether it was dish soap, vegetable oil, canola oil, whatever you chose, and you're going to want to put it in between the bags so it's about 2/3 full. Okay, once you have it 2/3 of the way full, you're going to want to go in with some more duct tape and tape that hole shut. Once you have that hole taped at the top, you're next going to get your bowl of cold water and your stopwatch device. Once your stopwatch is ready, you're going to take your bare hand, stick it in the water, and time how long you can let it last. So let me try. Okay, so you can see I lasted about 30 seconds with just my bare hand. Now, you might want to write that down so you remember. We're going to try and do this by sticking our hand in our fake blubber. The idea is that the liquid in this is going to act as our blubber and keep our hand a little warmer so we can leave it in the water longer. So, dry your hand off or use your other hand. Make sure it's nice and warm again, and we're going to repeat our experiment. Okay, if your hand's dry and nice and warm, it's time for round 2. I'm going to use my other hand for this test. So make sure you get it in there and be prepared to push start. Ready? Okay, I'm gonna stop it there. So this shows that I've been with my hand in our blubber for a whole minute. That's a whole 30 seconds longer. And honestly, I probably could have gone longer because it wasn't that cold, but for the sake of our video, I'll stop here. So if I lasted at least a whole 30 seconds longer with this on, acting as insulation, imagine how much warmer a seal would be if they had a nice thick layer of blubber on them. A whole lot warmer, right? And that's the end of our video. I really hope you enjoyed it and you learned a lot about heat, insulation, and just how seals stay a little bit warmer. Check out the library's YouTube page and see what other things you can learn. Until next time, see you later.